This is your time to rest, to breathe, and to let go of whatever the day has brought you. You're not here to race ahead or stay alert. You're here to slow down gently, like a spacecraft drifting through the dark with nowhere it has to be. There is no rush here. The pace of this story is calm, like the quiet movement of a satellite passing through the shadows of space, far from sunlight and sound. If your thoughts wander, that's okay. If you fall asleep before we finish, that's even better. This story is here for you, not to excite you, but to carry you softly into rest. There's no need to follow every word. Just let the rhythm take you wherever it goes. We live inside a galaxy, but it's easy to forget what that really means. The word galaxy often feels like an idea rather than a place. Something far away, something distant and full of stars. But the Milky Way is not just a shape in the sky or a name in a science book. It is our home, a great swirling collection of stars, dust, gas, and dark matter, spread across a space so large that the human mind cannot truly hold it. When we look up and see that hazy band of light across the night sky, we're seeing only a thin edge of it, just a narrow slice of something far too large to fully picture. Our entire solar system, everything we know, from the sun to the outermost comets, makes a slow circle around the center of the Milky Way. That orbit takes about 225 million years to complete. In the time since dinosaurs first walked the Earth, our solar system has only made one full lap. The galaxy itself is about 100,000 light-years across, which means that even light, the fastest thing in the universe, takes 100,000 years just to go from one side to the other. In miles, that's more than 580 quadrillion miles across. It's not a number we can feel in our bodies. It's a distance so large it becomes more like time than space. Even though we talk often about exploring space, the truth is that we have never left this galaxy. We haven't even come close. The farthest spacecraft we've ever launched, Voyager 1, is still deep within our galactic home, moving steadily but slowly through a space that remains part of the Milky Way. It took decades just to leave the solar system. Leaving the galaxy is something else entirely. It would mean moving farther than anything has ever moved. It would mean crossing a distance so large that our current technology doesn't even come close to handling it. Not yet. And maybe not ever. The idea of leaving the Milky Way carries with it a certain kind of mystery. Not just about what lies beyond, but about whether it's even possible. It's not just a question of building faster ships or launching stronger rockets. The problem isn't only technical. The real challenge comes from the very nature of the universe itself. Space is vast, and time moves slowly on the scale of stars and galaxies. The energy required to escape something as massive as a galaxy is enormous, and the journey would take longer than the age of many civilizations. It's not something we can rush. It's something we have to understand. At its heart, this question, why it might be impossible to leave the Milky Way, is not about limits in our imagination or even just limits in our tools. It's about the laws of physics, the nature of space, and the way time stretches over great distances. It's about what it means to move, and how much energy that movement really takes. And most of all, it's about the quiet truth that sometimes, even the most advanced ideas we have are still small in the face of the cosmos. This is not to say we should give up dreaming. But dreams are shaped by what's real, and this journey begins by looking clearly at what we're facing. Just like trying to climb a mountain, the first step is understanding how high it is, how far, how cold, how thin the air becomes. In space, the obstacles are different, but just as real. They come not from storms or cliffs, but from mass, from distance, from speed, from time. And if we are to imagine truly leaving our galaxy, we must understand those things not as distant theories, but as steady facts. Right now, we are bound to our galaxy in every direction. Not because someone is keeping us here, but because gravity holds us gently but firmly within it. The stars are moving, yes, and we are drifting too, but that drift is not enough to carry us out. The Milky Way is like a vast ocean, and we are still near the shore. We can see farther and farther out, but we have not yet found a way to cross it. The distance is only part of the challenge. The deeper difficulty lies in how space itself behaves over such great scales. The more we study the galaxy, the more we learn that it is not simply a collection of stars and gas. It has structure. It has layers. It has regions of dense stars and regions where only a few stars float, almost alone. And surrounding all of it is a halo of dark matter, an invisible mass that adds weight to the galaxy, even though we cannot see it directly. To leave the Milky Way, we would have to climb out of this invisible well, pushing against a pull that stretches for hundreds of thousands of light-years. It's not enough just to aim a ship outward. It would have to go fast enough, long enough, and with enough energy to break free. That's why this story is not just about engineering. It's about understanding limits that exist whether or not we build better engines. It's about time scales longer than any single human life. It's about machines that would have to work not just for years or centuries, but for hundreds of thousands of years. And it's about a kind of patience we are not used to thinking about. A patience measured in the quiet orbit of stars, or in the slow motion of galaxies that pass each other over millions of years. We often think of space as something we could one day cross like the ocean or the sky. But the galaxy is not just a sea. It is the entire map. Everything we know lives inside it. And leaving it would be like trying to step off the edge of the world, not into another land, but into a silence so wide that even light struggles to cross it. This silence is not empty. It is full of time, and full of distance. And to enter it, we must first accept that everything we've done so far has been within a very small part of a much larger whole. In the chapters ahead, we'll explore the limits that shape this journey. Each one is a piece of the quiet puzzle. The speed we can reach, the energy we can store, the dangers of space itself, the needs of the human body and mind, the way time bends and stretches across great distances, and the way even tiny errors in direction can lead to being lost forever. Each challenge is real. Each one is quiet. And each one tells us something about what it would really take to leave our galaxy behind. But before we begin, it's worth holding on to this thought. We are not stuck here. We are held here. And there's a difference. Being held means there's a connection. Gravity, yes, but also light and time and the long memory of where we come from. The Milky Way is not a cage. It is our home. A place made of stars, of dust, of invisible matter. A place where we grew, where we dreamed, and where we still look up at the night sky and wonder what lies beyond. So now, with that calm understanding, we begin. Slowly. Quietly. With the steady pace of thought that mirrors the slow turning of a galaxy. One layer at a time, we will look at the real reasons why leaving the Milky Way might be impossible. Not to give up, but to understand. Not to rush, but to see clearly. This is not a story of failure. It is a story of scale. And the deeper we go, the more we see how small we are, and how vast everything else has always been. The first and perhaps most quiet obstacle in our journey beyond the Milky Way is one that has been with us since we first began to understand how space works. It is not a machine we can build or a barrier we can break through by force. It is something more deeply rooted in the nature of the universe. That limit is speed. More exactly, the limit of how fast anything can move. At the heart of everything we do in space, from launching satellites to dreaming of distant galaxies, there is the quiet but absolute truth that nothing can travel faster than light. Light moves at about 186,000 miles per second. That sounds incredibly fast, and it is, especially compared to anything we have built. But on the scale of the galaxy, even light takes a long time to get from one place to another. A message sent at light speed would take over 4 years just to reach the nearest star beyond our sun. To reach the edge of the Milky Way, it would take light over 100,000 years. That's not a guess or a theory, it's a physical fact. No matter how powerful our rockets become, that speed remains the ceiling. And nothing with mass like a spacecraft or a person can even reach it. The fastest spacecraft we have ever built is Voyager 1, which is still moving away from Earth more than 40 years after it was launched. Its speed is about 38,000 miles per hour. At that rate, it would take more than 70,000 years just to reach the closest star. To leave the galaxy completely? That would require time beyond what we usually measure. We're talking not about years or even lifetimes, but spans of time longer than all of human history. Even with improvements in propulsion, the gains would still be small compared to what's needed to escape a galaxy. People often talk about future technologies, warp drives, wormholes, shortcuts through space itself. These ideas live in stories and theories, sometimes tied loosely to real physics, but always far beyond our current reach. In practice, these concepts come with enormous problems. A warp drive would need more energy than exists in the entire universe, just to move a small object. A wormhole would need to stay stable across billions of miles and for billions of years. Even if they could exist, which we do not yet know, they are not something we can build or rely on. Not now. Maybe not ever. Instead, we live in a world where all movement is slow when measured by the scale of stars. Rockets push against gravity with fire and force, but their speeds are limited by how much fuel they can carry, and how much heat they can survive. Even the most advanced concepts for propulsion, like ion drives or solar sails, are not fast enough to make a meaningful difference across galactic distances. They are useful for getting to nearby planets or maybe other stars in tens of thousands of years. But they do not bring the Milky Way any closer. There is a certain peace in this realization. It is not a failure on our part. It is simply the shape of the universe we live in. The speed limit is not there to frustrate us. It is there because of the way time and space are woven together. The faster something moves, the more its time slows down, the more energy it needs, the more it becomes part of the strange relationship between motion and existence. And because of that, the galaxy remains vast, not because we haven't tried hard enough, but because it truly is that large. Even if we imagine the most optimistic advances in space travel, where ships might move at 10% the speed of light, the numbers still show us the scale of the challenge. At that speed, it would still take 1,000,000 years to travel 10 million light years. It would take more than 1,000 years just to reach the outer edge of the Milky Way. And to go faster would require more and more energy, not in a straight line but in a curve that rises sharply, almost impossibly, the closer we get to light speed. That curve is not just technical. It is a hard truth in physics. There is no trick, no shortcut that can ignore the limits of acceleration. Every increase in speed comes at a cost. More fuel, more time, more structural stress. The faster a ship tries to go, the more it must protect itself from collisions with even tiny bits of matter. A single grain of dust, at a fraction of light speed, would strike with the force of a bomb. So the speed we want is not just hard to reach. It also becomes dangerous once we get there. The more we push, the more careful we must be. And care is heavy. Protection adds weight. And weight slows us down. Gravity is also part of this. Everything in the galaxy is held together by gravity, the stars, the planets, the dust, the dark matter. To escape that pull takes speed, and the deeper you are in a gravitational well, the more speed you need. Right now, we are not just sitting still in space. We are moving around the center of the Milky Way at about 500,000 miles per hour, carried along by the gravity of our galaxy. To break free from that pull, to climb out of the Milky Way's gravity well, would require more speed than any rocket has ever come close to providing. And the thing about gravity is that it never stops. It gets weaker with distance, but it never disappears completely. Even far beyond the disk of stars, the mass of the galaxy still pulls. To truly leave would mean overcoming not just the pull of the Earth or the Sun, but the soft, endless tug of the entire Milky Way. This is not a wall we can break through. It is a slope that never quite ends. A hill that stretches for light years. And climbing it means pushing against a force that is always there, always pulling us gently backward. So this is the first truth in our journey. That movement itself is limited. That speed has a ceiling, and getting close to it becomes harder with every step. That gravity is not a chain, but a deep ocean we are still far from swimming across. And that even our best ideas must face these facts. Not because we lack imagination, but because the galaxy is not built for easy travel. It is built to last. And lasting things are slow and wide and heavy with time. As we drift slowly through these thoughts, it's helpful to remember that even a spacecraft in the silence of deep space is never truly alone. It is part of this motion, part of the same gravity, the same speed, the same gentle curves that shape stars and systems. Our limits are not punishments. They are just the rules of a quiet, massive universe, still turning, still unfolding. A place where movement is slow but always steady. And where leaving the galaxy means not only building something fast but something wise. Something that can survive not just the miles, but the laws that govern them. When we talk about moving through space, we often imagine it as empty and weightless, like drifting through a still lake. But in truth, moving through space, especially over great distances, takes an enormous amount of energy. And when we think about leaving not just a planet, not just a solar system, but an entire galaxy, the numbers become so large that they begin to lose their meaning. To send anything across those kinds of distances, we need not just speed but something far more difficult to manage over time: energy that lasts. Every spacecraft ever launched from Earth has needed fuel. Rockets carry it in large tanks, often filled with chemicals that burn hot and fast, pushing the ship upward. Once that fuel runs out, the engines stop, and the spacecraft continues drifting forward, carried only by the momentum it gathered while it was burning fuel. In the vacuum of space, there's no air resistance to slow things down, But there's also no way to speed up again unless you carry more fuel with you. That's where the problem begins. Fuel has weight. And the more fuel you carry, the more energy you need just to move it. This is one of the quiet truths of all long-distance space travel. If you want to go far, you need fuel. But the fuel itself makes you heavier, and the more you carry, the more you need to carry just to move the fuel you already have. It becomes a cycle that grows quickly out of control. This challenge is called the tyranny of the rocket equation, and it's not just a phrase. It's a real mathematical limit that tells us how hard it is to keep going faster and farther when every step requires more energy than the last. Chemical rockets, the kind we use now, are good for lifting things off Earth and getting into orbit. But they burn quickly, and the energy they provide doesn't last long. Their energy density, which means how much energy they can deliver per unit of weight, is too low for deep space travel. Other kinds of engines, like ion drives or nuclear propulsion systems, are more efficient. They use less fuel over time and they can burn longer. But even these systems can only push a spacecraft so far. They help us move within the solar system. They cannot push us across the galaxy. To leave the Milky Way, a spacecraft would need to continue accelerating for a long time. It would need a constant, reliable source of energy, something that doesn't run out after a few days or weeks or even years. It would need fuel that can last for centuries or even millennia. And more than that, it would need to manage that energy safely without overheating or breaking down. Every system on the ship would need power. Not just the engines, but the navigation, the communication, the life support if humans are on board. That power has to come from somewhere. One of the most overlooked problems in space travel is not just how to produce energy, but how to get rid of it. Every machine, every computer, every engine creates waste heat. On Earth, we take it for granted that we can cool things down by using air or water. In space, there is no air, no wind, no breeze to carry heat away. The only way to release heat is through radiation, by letting it slowly leak away as infrared light. But that process is slow, and if too much heat builds up, the spacecraft can be damaged from within. Keeping systems cool over time becomes just as important as powering them. This balance between energy in and energy out is delicate. A ship that travels far from stars cannot rely on solar panels. There isn't enough light. Nuclear energy, like small fission reactors or even theoretical fusion engines, might work in theory. But we have never built such systems to last more than a few decades, and never in deep space. And even if we did, they would still produce heat that must be managed. Every watt of power becomes a question. How will it be stored? How will it be used? And how will it be cooled? Some people imagine that we might one day use antimatter, one of the most energy-dense substances known to science. A single gram of antimatter could, in theory, release more energy than a nuclear bomb. But we do not yet know how to produce it in large amounts, and storing it safely is another challenge entirely. If it touches normal matter, it explodes. That makes it incredibly dangerous, especially for long missions where there is no margin for error. Antimatter remains an idea, not a tool we can use. Even if we solved the problem of fuel, if we found something light, powerful, and safe, we would still face the problem of time. Energy must be stored for longer than any battery we've ever made. Systems must run without failure for centuries. Materials must survive the cold, the radiation, and the endless shaking of small impacts. Energy sources break down over time. Circuits age. Wires corrode. Even tiny things like sensors and seals can become weak after years of use. On Earth, we can repair them. In deep space, we cannot. It's not just about energy. It's about endurance. Energy that works in the short term is easy to find. Energy that works after 1,000 years is something else entirely. And yet that's the scale we're talking about when we dream of leaving the galaxy. A spacecraft may need to operate for 100,000 years before it even reaches the edge of the Milky Way. That means building systems that never stop. Or building systems that can repair themselves. Or building systems so simple and so stable that nothing ever goes wrong. Every solution so far brings more questions. If you carry fuel, how much will you need? If you use sunlight, how far can you go before it fades? If you use nuclear power, how long will it last and how will you contain it? If you use exotic fuels, how will you create them and where will you store them? And how will you cool everything once the systems begin to run? Each of these questions becomes more difficult as the journey becomes longer. And the journey to leave the galaxy is the longest of all. There is beauty in these problems, though, because they remind us that space is not just a backdrop, it is active. It pushes back. It demands patience and care. A ship that hopes to leave the Milky Way must be more than fast. It must be balanced, enduring, self-aware in a quiet, mechanical way. It must know how to warm itself without overheating, how to run without rest, how to cool without water or wind. It must be designed for a place where nothing helps, and where every choice must work for longer than any human life. In the quiet of deep space, energy is life. It powers the systems. It protects against cold. It keeps machines thinking and instruments measuring. Without it, even the most carefully built spacecraft would become a drifting husk, silent and dark. So every what must be managed, preserved, respected. And the deeper we go into space, the more precious that energy becomes. Not because there isn't any, but because using it wisely is the only way forward. So this is where we find ourselves, not just facing distance but facing the hidden costs of travel. Energy is not free. Fuel is not simple. And the farther we hope to go, the more we must design with deep time in mind. It's not enough to launch. We must also last. And in that lasting, in that slow and careful burn, lies the quiet truth of what it would mean to leave the Milky Way behind. When we think about traveling across the galaxy, we often picture machines, ships made of metal, engines burning quietly, antennas turning toward distant stars. But the truth is, if we want to send people on such a journey, the machines alone are not enough. The most complex part of the mission isn't just the engine or the fuel. It's the life inside the ship. Because people are not like probes or computers. People need food. People need water. People need air to breathe and a space that feels safe enough to stay alive. Not for days or months but for lifetimes and beyond. Every person on Earth lives within a delicate web of support. We breathe oxygen, which is made by plants. We drink water, which is cleaned and cycled by the planet. We eat food, which grows in soil that has been shaped by time and weather. All of this happens without us thinking about it. But if we leave Earth, if we step into the cold quiet of space, suddenly, every breath, every sip, every bite must be planned. Nothing can be wasted. Nothing can be left to chance. And when the journey lasts not just years, but centuries or more, even the smallest part of life support becomes a question of survival. In space there are no grocery stores, no rivers, no rain, no fresh air drifting in through a window. Everything a person needs has to be carried, created, or recycled. Oxygen can be made by splitting water into hydrogen and oxygen using electricity. But the system that does this must work perfectly, again and again for decades without breaking. And the oxygen has to be balanced with carbon dioxide levels, which means another system must remove the carbon dioxide people exhale. If that system fails even briefly, the air becomes unsafe. And fixing it can't wait. There is no backup planet nearby. Water is heavy, so carrying enough for a long trip is not possible. Instead, every drop must be recycled. Water from sweat, from breath, from waste, all of it must be cleaned and reused. This is already done on the International Space Station, but only for small crews and short missions. For a ship traveling through the galaxy, the systems must be stronger, more reliable, and able to repair themselves if something goes wrong. Water must keep moving in a perfect loop, over and over, for hundreds of years. A single leak, a single broken pipe could become a serious threat. Food is even more difficult. Packaged food lasts for a while but not forever. After a few years it begins to break down. It loses flavor, nutrients, texture. To feed a crew for a lifetime, food must be grown on board. That means soil, light, water, and space to grow crops. It also means managing pests, pollination, and nutrients in the soil, all without natural seasons or weather. Plants also help by releasing oxygen and removing carbon dioxide, so they are more than just food, they're part of the entire system that keeps people alive. But growing enough food for years in a small, closed space is one of the hardest parts of life support. The systems that make all this possible, air recycling, water filtration, food growth, must work together in a steady rhythm. Each one depends on the others. If one breaks, it affects the whole cycle. And in deep space there is no quick way to get help. No supply drops. No rescue missions. The ship must take care of itself and it must take care of its crew. That means redundancy, multiple versions of every system, ready to take over if the first fails. It means sensors to detect problems early and tools to fix them. But even that may not be enough. Because on such long missions, the systems must last longer than any human has ever lived. Right now, nothing we've built has ever lasted for 100,000 years. Not engines, not computers, not even buildings. And yet, if we imagine a journey across the galaxy, that's the scale we're talking about. A ship may need to support life not for one generation but for many. Children would be born on board. They would grow up without ever seeing a sky, a tree, or a river. The ship would be their world. And the systems that keep them alive would need to work not just like machines, but like ecosystems. Balanced, self-sustaining, and able to adapt. There's another quiet truth here. People are not only physical beings. We are emotional. We need comfort. We need space to move, light to see, a sense of time passing, and moments of peace. Long missions in tight, artificial environments can be mentally exhausting. Small problems begin to feel large. Tensions rise. Sleep becomes harder. So the life support system must also include space for rest, for exercise, for solitude and connection. Not just survival, but the chance to feel alive. The chance to feel human. That's why this part of the journey, keeping people alive over time, is more than engineering. It is a study in how we live. How we breathe, how we rest, how we grow. A spacecraft leaving the Milky Way would need to carry not just tools, but an entire world in miniature. And as hard as this is for a small crew, it becomes even more complex if the mission is longer than a single life. Imagine a journey so long that generations live and die aboard the ship before it ever reaches the edge of the galaxy. These people would inherit a mission they didn't choose, carried forward by systems built centuries before their birth. Their needs might change. Their culture might change. The way they use space, the way they eat, sleep, think, all of it could evolve. The life support system must be ready for that too. It must grow and shift along with them. There is no perfect model for this. We have not done it before. Our longest missions so far last months, maybe a year. But the mission to leave the Milky Way would stretch beyond memory. And every system would need to run like a slow heartbeat. Steady, reliable, unbroken. Even a pause could be fatal. So it's not about building systems that never break. It's about building systems that fix themselves. Or systems that can be fixed by those on board, with simple tools and clear knowledge passed down over time. This journey becomes, in many ways, a question of trust. Can we build something that will last not for us, but for people we will never meet? Can we create a ship that becomes a home, not just a machine? Can we carry not just fuel and food, but wisdom? The kind of wisdom that knows how to keep life going quietly in the dark? That is what life support really means, not just air and water, but a living system of care, of connection, of balance. A system strong enough to hold human life for as long as it takes. And still, in all this, the galaxy remains unchanged. It turns slowly. It waits quietly. It does not rush. It does not help. And so, we must prepare with the same quiet patience. To leave the Milky Way, we must bring with us all the tools of life. Not just the machines, but the patterns. Not just the systems, but the meaning behind them. We must carry a piece of Earth, not in shape, but in spirit. In the way we grow, the way we heal, the way we live together over time. And that may be the most difficult part of all. Not because it's impossible, but because it requires care that never ends. When we imagine a spaceship traveling through the galaxy, it's easy to picture the silence, the emptiness, the slow drift of stars passing by. But space is not as empty as it seems. Between the stars, between the systems, there are dangers we do not often think about, things we cannot see, things that move fast, and things that can harm. These dangers don't come in the form of space monsters or hidden traps. They come from something quieter, something always present in the universe. Radiation and tiny, fast-moving particles that can pass through almost anything. Radiation in space is not like the light we use to read or the warmth we feel from the sun. It is stronger, sharper, more invisible, and more difficult to shield against. Some of it comes from the sun in the form of solar flares or solar storms, where bursts of charged particles are thrown into space. These events are powerful but also somewhat predictable. Closer to the sun, we can see them coming. We can prepare. We can build shields, hide in protected rooms, or power down systems. But the farther we go from the sun, the more we leave behind its light, and the more we enter a sea of radiation that comes from everywhere and nowhere. This background radiation, which fills the galaxy and beyond, is made up of cosmic rays. These are not rays in the usual sense like beams of light. They are particles, mostly protons, moving near the speed of light. Some were born in exploding stars, others in distant galaxies, accelerated by black holes and powerful magnetic fields. They have been traveling for millions of years, and they don't stop when they reach a spacecraft. They pass through metal. They pass through plastic. They can even pass through the human body, damaging cells as they go. On Earth, we are protected by the atmosphere and by the magnetic field that surrounds the planet. These layers block most harmful radiation before it ever reaches the ground. Even in low Earth orbit, astronauts are still inside the safety of this shield, though it is thinner up there. But outside of it, out in deep space beyond the planets and the sun's protective bubble, there is no shield left. The radiation is constant. It is low in strength from moment to moment, but powerful over time. And time, as we know, is what matters most in a journey across the galaxy. Radiation does not cause immediate pain or sickness, not at the levels found in deep space. It's not like standing next to something hot or bright. It works slowly, changing the structure of cells, weakening tissues, increasing the risk of cancer, damaging DNA in quiet, invisible ways. For short missions we can take the risk. For long ones we must do more. We must protect. But protection brings its own problems. Because the only reliable way to block radiation is with mass. Thick walls, dense materials, layers that can slow or stop the particles before they reach what's inside. That means adding weight. And in space travel, every pound counts. The more mass a ship has, the more fuel it needs. The more fuel it carries, the more mass that must be moved. It is a quiet cycle that makes every choice important. Do we carry more shielding and move more slowly? Or do we move faster with less protection? And what happens if the systems fail, if the power goes out or the walls wear thin over time? Radiation does not wait. It is always there, passing through, marking its presence in the structure of machines and the bodies of the people inside. Some spacecraft designs imagine using water as shielding, since water is good at absorbing radiation and also needed for life. Tanks of water around living areas could serve two purposes. But water is heavy, and storing it in the right shape and keeping it clean is not easy. Other ideas involve placing sleeping quarters in the center of the ship, surrounded by food supplies and waste recycling systems, using every available material to block particles. Some designs even suggest using magnetic fields, trying to mimic Earth's own shield. But those systems are complex, delicate, and not yet reliable for long-term missions. The deeper problem is time. A little radiation can be managed. A lot, over a short period, can be dangerous. But low levels, for decades or even centuries, create a slow and steady threat. Materials become brittle. Electronics age faster. Living cells begin to change in small, harmful ways. There is no moment of alarm, just a long, quiet erosion of safety. And because the journey to leave the galaxy is not measured in days or years, but in lifetimes, this slow erosion matters. It becomes part of the ship's story, a silent force always present. Then there are the physical particles, small grains of dust drifting through the interstellar medium. These bits of matter are tiny, some no larger than a grain of sand, but they are moving fast. At the speeds needed for interstellar travel, even something that small can cause great damage. The faster the ship goes, the harder it gets hit. A single collision could damage sensors, crack panels, or even puncture the hull. Unlike radiation, which passes through, these particles strike with real force. The ship must either avoid them, which is hard, or be built strong enough to take the hits. Some designs suggest placing a shield at the front of the ship, a thick layer of material to absorb the impacts. Others imagine small drones flying ahead, mapping the path and clearing debris. But again, each of these adds complexity, weight, and the need for energy. Every solution must last not just for one trip, but for all time. A ship traveling across the galaxy cannot stop at a station for repairs. It cannot call home. It must endure everything, radiation, collisions, system failures, on its own in the silence between stars. The further the ship travels, the farther it gets from help. And the more time it spends in deep space, the more it becomes part of that space. Systems change. Its materials age. Even the metal itself begins to change at the atomic level, as radiation shifts the bonds between atoms, making the structure weaker, more fragile. These are not things we can see with the eye. They are slow changes, unfolding over decades, but always moving forward. Always present. And if people are on board, these changes matter even more. Because people are soft. We are made of water, of cells, of things that break and heal. Radiation does not care about healing. It only pushes forward, leaving small marks with every moment. And the longer we stay in space, the more those marks add up. Not just in the body but in the mind, in the way we think and feel and sleep. Being exposed to radiation for long periods can affect memory, attention, even mood. It becomes a hidden force, shaping the journey in ways we don't always expect. But even with these challenges, we do not stop wondering. We look at the stars and still ask, what lies beyond? What would it take to go there, not in imagination but in reality? And the answer, at least in part, is this: it would take more than fuel, more than speed, more than strong engines. It would take a way to protect what's inside. To guard not just the ship but the people. To block what cannot be seen. To slow what cannot be stopped. And that is why radiation, though silent and invisible, is one of the greatest limits we face. Not because we haven't tried to solve it, but because it is woven into the shape of space itself. It is part of the galaxy, part of the emptiness, part of the long path between stars. If we want to walk that path, we must bring not only courage but care. We must protect life in a place where nothing protects it. And we must do it for longer than we've ever tried before. So as we drift deeper into this story, let's remember this quiet truth: that space, though beautiful, is not gentle. It is full of things that move without sound and strike without warning. To survive that space, a ship must be more than fast. It must be strong, it must be quiet, and it must be ready for a journey where every particle, every beam, every moment of light and dark becomes part of the long, slow challenge of going beyond the stars we know. In the quiet of space, time does not pass in the same way it does on Earth. Out here, without sunrise or sunset, without the ticking of clocks tied to human habits, time becomes something else. Slower in some places, faster in others, stretching and folding in ways that are hard to feel but easy to measure. This change is not just a thought experiment. It is part of the way the universe works. And when we begin to think about leaving the Milky Way, we must begin to think about time, not just how long the journey would take, but how the journey itself would change time for those on board and those left behind. This idea comes from something called relativity, one of the most carefully tested and well understood principles in physics. It tells us that time is not fixed. It flows differently depending on how fast you're moving and how close you are to a source of gravity. On Earth, we don't notice it. The differences are tiny. But in space, especially at high speeds or near massive objects, time can behave in ways that feel strange. A spacecraft moving very fast will experience time more slowly than the people it left behind. And the faster it goes, the more extreme the difference becomes. If a ship were to reach a speed close to the speed of light, the people on board would feel time moving normally for them, eating meals, reading books, sleeping and waking up. But to someone back on Earth, years or even centuries could pass in what feels like days to those on the ship. This effect is real. It has been measured with fast-moving satellites and atomic clocks. It's not science fiction. It's part of the fabric of space and time itself. And as we imagine a journey across the galaxy, we must imagine not only traveling through distance, but through time, in a way that separates people forever. This becomes more than a technical problem. It becomes a human one. Imagine a crew leaving Earth on a ship that travels at high speed. For them, perhaps only 10 years pass. But by the time they reach the edge of the galaxy or send a message back, thousands of years have passed on Earth. Entire civilizations could rise and fall. Languages could change. The people who launched the mission would be long gone. Their world, their culture, their questions, forgotten or transformed. The ship would still exist. The people on board would still remember. But the connection would be lost. Even if communication were possible, it would be painfully slow. Messages sent from the ship would take thousands of years to reach Earth. And replies, even if someone were still there to answer, would take just as long to return. It would be like speaking into a canyon so deep that the echo returns only after generations have passed. There could be no real-time conversation. No guidance. No comfort. No news from home. Only silence, broken by the long, slow flicker of a message crossing space and time. And what if the ship returns? What if it somehow completes its journey and heads back to Earth? It would arrive to a future it does not recognize. A world changed in ways the crew cannot imagine. Their families would be gone. Their history erased by time. Their ship, once a wonder of human engineering, might return as an artifact from the past. An old machine floating into a world that sees it as a mystery. The people who stepped onto the ship would find that the Earth they left no longer exists. Not because the planet changed, but because time carried it far beyond them. For some, this might sound sad, but it's also a quiet, powerful truth about the scale of the universe. Space and time are not separate. They are one thing shaped together. And when we move through space, we also move through time. We can't help it. Every mile we travel is also a moment we experience differently. And when the miles become light years, the moments become ages. To leave the Milky Way is not only to move far away. It is to move ahead in time, to drift forward while the rest of the universe continues without us. There is something almost poetic about this. A ship moving fast enough could escape many of the problems we face here. It could leave behind conflict, disaster, change. But it would also leave behind joy, growth, connection. It would carry its own time inside like a bubble, always moving forward but never in step with the rest of the universe. For the crew, life would go on. But for the world they left, life would go on differently. The two would never fully meet again. Time would stretch the distance until even memory begins to fade. And if the ship carried no people, if it were only machines, probes, data, it would still face the same problem. The data it collects might take thousands of years to return. By the time it arrives, the questions that led to the mission might no longer matter. The language used to send it might be forgotten. The systems built to receive the signal might no longer exist. And yet the ship would continue. Quietly, steadily, sending its message through a sky that has changed, toward a home that may no longer be listening. So when we ask why it might be impossible to leave the galaxy, time itself becomes part of the answer. Not just because the journey is long, but because the journey changes what it means to travel at all. To go far is to go forward. And to go forward is to leave something behind. That truth doesn't stop us from wondering, but it does help us understand what the journey really asks of us. It is not just distance that separates us from other galaxies. It is time, and time in space is never simple. Even today, the clocks on GPS satellites must be adjusted for relativity. They orbit high above Earth, and time moves a tiny bit faster for them than it does on the ground. If we didn't correct for that difference, our location systems would slowly drift and fail. That tiny effect, just a few billionths of a second, must be accounted for every day. Now imagine multiplying that effect by thousands, by millions. Imagine a ship moving fast enough that days on board equal centuries on Earth. That is the scale of relativity in deep space. Not imaginary, not avoidable, just real. And yet, within this slow truth, there is still a kind of peace. Because time and space, though strange, is not cruel. It simply flows as it must. It bends under speed. It stretches under gravity. It moves forward in a steady rhythm like the pulse of a star. For those who travel far, time becomes something different. Not a race, not a countdown, but a quiet, ongoing presence, always with them, always marking the journey in a way no clock can fully hold. To travel this far would mean accepting that. Accepting that the journey itself changes not just where you are, but when you are. Accepting that you may reach a place no one remembers at a time no one expected. Accepting that the story you carry may outlast the world that sent you. These are the soft limits, the ones we don't always see. They do not break ships. They do not crash missions. But they shape everything. Because a mission across the galaxy is not just about arrival. It is about becoming something different, because time, like space, cannot be left unchanged. So if we build such a ship one day, and if it launches quietly into the deep dark, carrying people or not, it will drift not just through the stars, but through the ages. It will carry a part of now into the long future, into the quiet turning of time that only space allows. And maybe, somewhere far from here, it will be found. Or maybe not. But either way, it will have moved in a way that changes what it means to be from here. And in that motion, it will remind us of what time really is, not something we control, but something we enter. Gently, slowly, and with deep respect. Deep in the vast silence between stars, navigation becomes not just a matter of direction, but of almost unimaginable precision, because even the smallest error at the beginning of a long journey can grow into something enormous over time, like the slow widening of ripples across a still lake until they become waves you can no longer ignore. Imagine steering a craft through space where there are no roads, no signposts, no landmarks that stay still, but only the faint light of distant stars that themselves are moving, all drifting in an endless dance guided by gravity and age. If your path is off by even the tiniest fraction of a degree at the start, over millions of miles that tiny misalignment can become a yawning distance, so large that the object you meant to reach is no longer within sight, no longer reachable, possibly even forgotten. In deep space, distance and time are partners, stretching each other ever larger, and navigation must be so careful and so exact that the ship becomes, in a way, its own universe, its own constant reference point in a sea of motion that never stops. This means that the systems guiding the ship must be unimaginably reliable, able to function for ages without recalibration, without outside help, and without the comforting certainty that comes from knowing where you are in relation to something solid like a planet or a moon. On Earth, pilots and captains can check their position against landmarks, against known maps, against the steady pull of gravity that keeps everything in place. In space there is no such comfort, and the farther you go the more difficult it becomes to define here and there, because everything is moving, everything is changing, and the galaxy itself is not fixed but slowly evolving. Stars that were in one place when a journey begins may have shifted many light years by the time a ship arrives where it hoped to be, and even the brightest of them can seem faint or disappear entirely behind clouds of dust and gas. The navigation systems must not only know how to move the ship, but how to understand the changing background of the cosmos, how to sense tiny differences in starlight, how to measure shifts in gravity, and how to adjust for them with mechanisms that never tire. There is no GPS out here, no central beacon broadcasting a signal that a ship can lock onto. There is only the steady flicker of old stars and the deep silence of vast regions between them, and so navigation becomes an art of patience, precision, and quiet confidence in the machinery that must not fail. And that confidence is the idea of creating machines that can endure beyond the lifespan of their creators invites a kind of quiet reflection on what it means to trust technology, to invest in something that may never be seen again, yet must continue working long after the names of those who built it have faded from memory. It is not just a technical requirement, it is a philosophical one, because it demands that we think of our creations not as temporary tools, but as enduring companions on a journey we ourselves may never complete. The navigation systems must treat every signal, every calculation, with reverence, knowing that a single misstep could send the ship off course forever, turning a hopeful voyage into a wandering drift across the emptiness between galaxies. And so navigation becomes not just a science of direction, but a craft of trust, patience, and slow, steady precision, where every adjustment is made with the understanding that the journey is long, the environment is indifferent, and the only real guide is the careful and constant maintenance of systems that cannot fail. In the stillness of space, with stars slowly shifting and light taking centuries to travel from one point to another, the reliability of the ship's navigation systems becomes a quiet testament to human hope and careful design, woven together in circuits and codes that must hold together like a woven tapestry against the pull of time. And in that tapestry, every thread must be strong, every connection must endure, and every memory must be kept safe, for the path out of the Milky Way is not marked by roads or signals, but by the quiet precision of systems that refuse to forget their purpose, even as ages pass in silence around them, and even as the ship itself becomes part of the silent, slow motion of the universe it is trying to leave behind. Inside the walls of a spacecraft traveling through the dark, human life must continue in a space where no wind blows, no birds sing, and no new landscape ever appears on the horizon. The stars outside the window remain fixed, too far away to seem real, and the silence becomes the most constant sound. Time stretches differently in such a place, not because clocks stop, but because days begin to lose meaning. Without sunrise and sunset, without seasons, without the small changes that color life on Earth, the mind begins to wander. And when it wanders too far, it begins to feel alone, even in a room full of other people. This kind of isolation is not like being alone for a few hours or even a few days. It is a slow unfolding of distance, not just from places but from experience itself. Earth becomes a memory, and that memory fades not all at once but piece by piece as the details grow quiet and soft. The smell of rain, the feel of real gravity, the sound of leaves rustling, these things slip away over time like dreams in the morning. The ship becomes the only world that exists, a world made of metal, air filters, repeating routines, and narrow corridors. And the people inside it must learn how to find meaning in this repetition, in this smallness, in this absence of change. At first it might feel manageable. People adjust. We are good at adapting, especially when we know there is a reason. But as the days stretch into years and the years stretch into lifetimes, the emotional weight begins to build. There is no escape from the environment, no new place to explore, no way to step outside and feel space as anything but a barrier. Even conversations can start to feel like echoes. The same voices, the same stories, the same memories replayed. Without care, monotony becomes more than boring. It becomes something heavy, something that presses on the mind and pulls at the spirit. To survive this kind of journey, humans need more than air, water, and food. They need connection, stimulation, and space to think. They need beauty. On Earth, beauty is all around us, often without effort. A tree swaying, a bird's call, the change of clouds across the sky. In space, those small gifts are gone. They must be created, preserved, or imagined. Art becomes important. Music, shared meals, celebrations, even if there is no calendar to mark the seasons. People must bring meaning with them or build it as they go, piece by piece, day by day, with intention and care. Psychological health is not something that takes care of itself in space. It must be protected like oxygen. It must be planned for, supported, and given room to change. On long missions, crews might face stress not just from boredom but from conflict. Even among people who care about each other, being in a small, closed space for too long can make small disagreements feel large. And without space to be alone or without the chance to leave and return, those feelings can grow. The ship must be built to offer both community and solitude. Spaces to be together and spaces to be alone. Not just physically but emotionally. Sleep can change. Dreams become strange. Some people might feel disconnected from time itself, unsure of what day it is or what season it might be back on Earth. Others might lose their appetite not because of food but because of the sameness, the loss of desire. These are not failures. They are human responses to a world that does not shift, that offers no surprise. The mind craves variation. Without it, even joy begins to feel dull. So the systems that support life must support the mind as well, not with noise or distraction, but with quiet forms of nourishment that renew the sense of purpose. And what of those born on the ship? If the journey is long enough, some people may live their entire lives without ever stepping on a planet. They would learn to walk in artificial gravity, to speak in the ship's quiet tones, to see the stars not as something distant, but as a permanent background to life. For them, Earth would not be home, would be a story. A place in pictures, in lessons, in old recordings passed down. Their culture would be shaped not by land but by walls. Not by oceans but by airlocks and control panels. And still, they would search for meaning just like we do now. Mental health in space is also affected by time. Over months, people feel homesick. Over years, they may feel untethered. Over generations, identity shifts. The crew may begin to see themselves not as travelers from Earth, but as people. Technology can help. Virtual environments might offer glimpses of Earth, or new experiences designed to break monotony. Simulations of forests, of oceans, of city streets filled with light. But these tools, while helpful, are not complete solutions. The mind knows the difference between what is real and what is not. Still, the gesture matters. The effort to create softness, to bring peace into a space filled with machinery, is part of what makes a place livable. Plants can grow in hydroponic gardens. Light can be tuned to mimic the changing color of a sky. Small things, carefully chosen, can ease the pressure on the heart. Communication with Earth, even if delayed, becomes a vital connection. Messages sent and received may be spaced by years, but they carry more than words. They carry the sense of being remembered, of being part of something larger. And even if Earth is no longer reachable, the memory of it, the story of it, can be kept alive through ritual, through language, through the simple act of telling and retelling where we came from. This is how culture survives in deep space, not just through data but through shared meaning, carefully passed from one voice to the next. A ship crossing the galaxy must be a home in more than name. It must offer not only shelter but comfort, not only systems but symbols. A place where people can grow even if they never set foot on soil. Where children can laugh, where music can echo, where silence can be chosen and not forced. These are not luxuries. They are the things that make life possible over time. The things that keep the mind from closing in on itself, from shrinking under the weight of unchanging days. Isolation is not always loud. It does not always feel like fear. Sometimes it feels like nothing at all, a slow fading of feeling, a quiet drift away from the richness of life. That is the danger. Not dramatic breakdowns but a slow loss of wonder. A ship built to leave the galaxy must carry more than fuel. It must carry joy and surprise and the chance to feel something new. It must carry stories and questions and the tools to create. Because in the long dark, those are the things that make life continue, not just the body but the self. So we arrive at another limit, not in machines or physics but in people. A soft human limit. The need for connection. The need for meaning. The need for something to wake up for even when the view outside the window never changes. And that may be the greatest challenge of all. Because to leave the galaxy is not only to cross space, but to carry ourselves across time without losing who we are. To remain human even when Earth becomes only a memory. And to find, even in silence, something worth singing about. There is a moment, imagined in stillness, where a spacecraft, alone and patient, drifts past the last faint edge of the Milky Way. It does not burst into another galaxy or cross a clear boundary. It simply moves forward, one small motion after another, into a darker, quieter part of space where the stars behind begin to gather into a shape, and the stars ahead grow sparse. This moment is not marked by sound or celebration, only by a slow unfolding of distance, a shift in perspective so wide it no longer feels like a direction. And in that soft turning, the ship becomes part of something older, something deeper than travel. To look back from such a place, back toward the spiral arms of our home galaxy, is to see not a place we left, but a place that holds everything we ever knew. Every mountain, every ocean, every breath of air. Every story ever told, every name ever spoken, every idea ever written down. All of it lives in that narrow band of light, wrapped in soft starlight, tucked between rivers of gas and dust that bend with the motion of time. From out here, the Milky Way is not just home. It is history. It is family. It is the great quiet nest in which life once began, and maybe still quietly blooms in places we have never seen. There is a kind of peace in seeing it from afar, not in leaving it behind but in understanding that we were always part of something vast. The stars do not shout. The galaxies do not demand. They simply are, turning with slow grace, like leaves caught in the still current of a deep lake. That motion, almost invisible to us, unfolds over millions of years, shaping the way matter gathers and spreads, creating spirals not for beauty, but because gravity pulls and curves when it has time. And out here, time is all there is. Time and space and the light that travels across both. The Milky Way is not alone. Beyond it, other galaxies spin and drift, each holding their own suns, their own planets, their own dust. Some are older, some are larger, some are shaped differently, but they all seem to glow with the same quiet patience. They do not speak to us. They do not wait for us. They are not part of a story where we play the leading role. And yet, somehow by seeing them we feel something close to understanding. Not because we can explain them fully, but because we can feel their stillness. Their silence is not emptiness. It is calm. It is a reminder that the universe was never meant to be loud. To imagine ourselves drifting out toward these distant lights is not to imagine conquest or discovery. It is to imagine acceptance. A letting go of speed, of pressure, of the need to solve every mystery before the sun sets. It is a kind of surrender, not to defeat, but to scale. To the truth that some distances will always be greater than our reach and some questions may remain unanswered, not because we failed but because they belong to a different rhythm. A slower one. One we can join only by being quiet long enough to hear it. This is what awe feels like when it's not sharp but soft. When it does not strike but settles. When it doesn't ask for fear or urgency or even amazement. Just stillness. Just breath. Just the slow settling of thought into the understanding that the universe does not revolve around us, but includes us, gently like a tide includes a pebble, like a forest includes a single leaf. We are not separate. We are not special in a loud way. We are special in the way that everything is, because it exists, because it belongs, because it continues, and the galaxy continues. Whether or not we leave it, whether or not we ever find a way to cross the space between stars, it turns. Its arms stretch and curl. Its stars are born, live brightly and quietly die. Planets form, grow, change and sometimes break apart. Dust gathers. Light bends. And in all of this there is no rush. The universe does not count time the way we do. It does not need to arrive. It only needs to be. And perhaps, if we can match that rhythm for a moment, we too can feel the kind of peace that does not need to end. In that peace we find not only humility but belonging. The idea that we are small does not have to be frightening. Small things are part of large things. A cell is part of a body. A droplet is part of a wave. A single star, like our sun, is part of a galaxy that is part of a cluster that is part of the greater structure of the cosmos. We do not need to be large to be meaningful. We only need to be present. And presence in space is everything. Just being here, alive, aware, curious, is its own kind of light. So when we think about leaving the galaxy and we say that it might be impossible, we are not closing a door. We are simply recognizing the shape of the room. We are seeing the walls not as traps, but as the edges of something beautiful, something real. The Milky Way is wide. It is old. It is more than a place. It is a story we are still telling, a home we are still discovering, even as we look outward. And if we never truly leave it, that does not make us less. It only reminds us how much it still has to give. Because sometimes the answer is not to go farther, but to go deeper. Not to cross the space between stars, but to understand the space we already live in. To feel it more fully. To breathe in its quiet complexity. To listen to the way time speaks not in seconds, but in cycles, in light, in gravity, in the slow unfolding of stars. That listening is a kind of journey too. One that does not need engines or fuel. One that begins with stillness. One that leads to wonder not by moving but by noticing. And in the noticing, we become part of the galaxy in a new way. Not as explorers. Not as passengers. But as witnesses. As living proof that the galaxy has brought forth not only planets and stars, but eyes to see them, minds to wonder, and hearts to feel their quiet pull. We are not separate from the spiral. We are one of its expressions. One of its soft turns. One of its long thoughts made briefly solid. And that in itself is enough. That in itself is the kind of awe that needs no more. So now we've reached the quiet end of a very long thought, a thought that carried us across light years of space and through ages of time, not with the speed of rockets or the noise of launches, but with steady, quiet steps. We began with a simple question, soft but profound. What would it mean to leave the galaxy? What would it take, in reality, not in fiction or fantasy, but in the slow unfolding of true physics, of real effort, of long patience? And as we followed that question, we saw the many shapes of the answer, not as walls or warnings, but as contours, natural limits, gentle boundaries that ask not for ambition, but for understanding. These limits are not failures. They are the way space holds itself together. The galaxy, wide and slow in turning, has shown us its depth, not just in distance but in design. We saw how hard it is to move fast through a universe that resists speed. We saw how much fuel it takes to keep going, how much energy must be stored and released and cooled, all without fail. We saw what it means to carry life, not just in the body, but in the system that keeps breath moving, water flowing, food growing in the dark. And with every new layer, we saw that going far means going carefully. It means moving not just through space, but through every part of what makes something last. We followed the trail through radiation, through the sharpness of particles that do not sleep, through the way space itself wears down metal, glass, bone. We passed through time, where clocks stretch and bend, where the seconds of one place become centuries in another, and where the idea of returning changes from a plan to a question. We looked into the mind, the heart, the spaces between thoughts, where solitude grows and meaning must be made again and again in small ways. We understood that people are not just travelers, they are homes within the home, and their well-being is the journey too. And then we paused. We looked back. Not in regret, not in sadness, but in awe. We saw the Milky Way not just as a place we might leave, but as a place we are deeply part of, whether we move or stay still. We saw that the galaxy does not rush. It does not demand that we go. It turns slowly, with or without us, and in its turning, it offers something rare: time to listen, time to rest, time to understand that to be small is not to be weak, that to remain is not to be lost, that sometimes the most profound journey is not outward, but inward, into attention, into stillness, into quiet being. And now, with all of that gently behind us, we arrive at this soft ending. Not a conclusion, but a place to pause. A space to let the thoughts settle, like dust in low gravity, slow and spiraling. Perhaps you are already drifting, eyes half closed, your body resting more deeply than before, your breath a little slower. That's all right. That's the shape this story was always meant to take. Not a destination, but a descent into calm. The galaxy will still be here tomorrow. The stars will still rise even if we can't see them. The distances will still unfold, mile after mile, light year after light year, quietly patient, quietly present. The truth we've explored is not hard. It's wide. It asks for breath, not effort. It reminds us that there is no shame in limits, that boundaries are not barriers, that impossibility, when met with care, becomes a kind of beauty. Because in that space, where effort meets nature, where ambition meets scale, we find something more enduring than success. We find peace. A soft, strong kind of peace that does not break when touched. A peace that says, you are part of this, even now, even here, even if you never leave your bed. And if this story brought you rest, let it remain with you like a long exhale, like a star that keeps shining, even when your eyes are closed. Let the thoughts stay soft. Let the night be gentle. And if you'd like, you can return to this place again. You can replay the journey, not to remember the facts, but to feel the rhythm. Because the rhythm is the point, the steady pace, the quiet unfolding, the sense that there is space enough to breathe. So wherever you are, wherever you're listening from, whether the city lights